Hi, I'm Angelo Malonis, and this is my cloud computing project. Over the next few minutes, I'm going to walk you through what I built, why it matters, and show it running live. Every cloud application faces the same problem. Workloads aren't constant. Some days nobody uses an app, and some days everybody does. So if you build for the busy day, you'll always have inactive space or workers wasting money. And if you build for the quiet day, you won't have enough capacity to handle a busy day when it comes. If you're wondering how Uber can handle Friday night surges without running a million servers 24/7, this is how. Essentially, they don't keep the capacity sitting around. They just spin it up when work arrives and tear it down the moment it's done. What I'm going to show you today is exactly that pattern, built from scratch. Event-driven compute that scales to zero when idle, using image processing as the driver. A common analogy for this scenario is owning a photo processing store. Some days you might only get 2 customers, and some days you might get 200, and you can never tell which day is going to come. So you have 2 solutions. You can either hire 2 employees to manage the quiet day, and then on a busy day, they're completely overloaded and you have to turn customers away. Or you can hire a massive team of employees, effectively paying their salary even when you only have 2 customers. So the cloud solution is basically hire freelance, independent people as much as you need them. So on a quiet day, if you only get 2 purchases, you simply hire these 2 freelancers, they do the job, and then as soon as the job's done, they no longer work for you. So it's able to handle quiet days and busy days equally as effectively. Here's how it's built. A user submits an image through a React front end hosted on S3 with CloudFront in front of it for global delivery. That hits an API gateway, which triggers a Lambda function, which is serverless code that only runs when it's called. The Lambda does 3 things in under a second. It stores the image in S3, it writes a job record to DynamoDB, and it drops a message in the SQS queue. This queue is the heart of the system. The API doesn't know or care about the workers, and the workers don't know or care about the API. They just agree on a message format stored here. On the other side of the queue, ECS Fargate runs containerized Python workers. They long poll SQS for jobs. When a worker picks one up, it downloads the image from S3. It runs 5 transformations: thumbnail, medium, grayscale, blur, and edge detection, and writes the results back. Meanwhile, CloudWatch watches the queue depth. When messages pile up, it triggers an auto-scaling policy that adds more workers. When the queue drains, it scales them down. And everything you see, all 10 AWS workers, is defined in Terraform. Infrastructure is code. One command deploys it and one command tears it down. So this is what the dashboard looks like, and I'm going to give you an example with one image submitted. So I'm going to take this image here and I'm going to drop it. So unfortunately, Fargate takes a little while to boot up, so I just fast forwarded quite a bit. But here you can see the queue depth. I upload the image at 419. The queue depth jumps to 1, and it sits there for quite a while. We deploy 1 worker, and the job is completed quite quickly, and that worker stays active for quite a while as well. Here we can see the actual job we submitted, and it was completed in 600 milliseconds. Now we'll demonstrate the same process, and we can also see in the dashboard on AWS, it receives the upload at 419, and it deploys the worker at 422. And we can see it deploys that 1 worker as well, and it's still running because it's scaled up. Now we'll demonstrate what it will look like if I run 25 jobs at once. So again, every job is a cold start, so it takes a little while for it to fully reflect what's going on. But here we can see the queue depth has jumped up to 13, and I'm just going to cut this and resume when it finishes. So the 25 jobs has officially stopped running. As you can see here, just from the terminal, I'm able to access it right from when I submitted all the images. So you can see it downloading and uploading to S3. Following that, it begins, I just gotta scroll down a little bit more. It begins doing the transformations to the image. So you can see it for this image: thumbnail, grayscale, blur, edges, etc., etc. It does that to every image. Unfortunately, it only deployed 1 worker again. The jobs run very quickly. So as you can see here, 215 milliseconds, 288 milliseconds, 201 milliseconds. So it wasn't actually able to scale up any more workers. But I'm going to demonstrate 200 jobs here and see if we can get some more workers going. So it's been about a minute and a half, and I'm still waiting for the active workers to queue up. But in the meantime, I've actually set up this query, which delivers us what the queue is sitting at, the desired workers we want, how many are running, and how many are pending. So it appears the 200 jobs have finished. It spun up 4 active workers total is all it needed. And I just want to demonstrate. It spat this out super quickly, almost all at once. And we can see the queue goes from 200, spins up sets 4 desired workers, still the queue 200, got 2 of them running, queue jumps down to 188, gets 4 of them running, and within less than a second, queue goes from 188 to 12, just because the jobs go so quickly through. It does take a while to spin down the active workers, I've learned. But yeah, that's pretty much how it works. This is a quick visual in the CloudWatch dashboard. You can see this is when we spun up that one job, single job. This is when we sent the 25 into the job submission rate. This is when we sent in the 200 jobs. And yeah, you could see the queue depth go 125, 200. So before I wrap up, I want to quickly demonstrate the folder structure and just how the project was built. So most of what we've seen lives in the Terraform folder. So ECS.tf for the worker service, Lambda for the functions, SQS for the queues, and autoscaling for the scaling policies. The Lambdas folder, this is where the 4 Python functions live, one for submitting jobs, one for getting the job status, one for current metrics, and one that queries CloudWatch, which powers a live chart that we saw earlier. The worker folder is the Python container that processes the images. So it contains a Docker file, the main polling loop, and the pillow transformation logic. And then finally, we have the front end, which contains hooks, components, API client, and a bunch of pieces to make the dashboard work. So it's been a few minutes, and as you can see, all the workers have stopped, and they ended their work at 4:39. So to recap, basically what I built was an event-driven auto-scaling job processing system that uses SQS for decoupling, Fargate for elastic compute, DynamoDB for state, CloudWatch for the observability that drives scaling decisions, and all of it is defined in Terraform. This is the pattern behind every serious cloud application you use every day. Netflix encoding your show, Uber routing your ride home, and Stripe processing your payments. What you just watched is a miniature version of the same architecture that runs at planetary scale. Thanks for watching.